If I ask you, tell me a name of a metal which is liquid at room temperature, immediately you will get an answer as mercury. What if I tell you there is another metal which is also liquid at room temperature? Yes, gallium. It's another metal to be liquid at room temperature. Hi everyone, I am Shalu and today we will discuss about a smart future metal, gallium. Now in this video, we will discuss about physical and chemical properties of gallium, some of the interesting behavior that it shows, and we'll also know why it is called as smart future metal. So let's see about the physical properties of gallium. Gallium is very soft as solid, so soft that it can be cut with a knife, and it has a silvery white appearance. In liquid state, gallium tries to occupy minimum surface area just as mercury, but it clinches to the surface. When you will remove liquid gallium from your hand, you will have silvery black patch on your hand. Gallium has a symbol of Ga and its atomic number is 31, atomic weight is 69.723. It has an orthorhombic crystal structure. It lies in group 13, period 4 of the periodic table. It has two isotopes, Ga69 and Ga70. The composition of gallium found in nature is Ga69 is 60% and Ga71 is 40%. The melting point of gallium is 29.7 degrees Celsius and boiling point is 2204 degrees Celsius. Such a low melting point and such a high boiling point. These two play an important role in the different interesting properties that gallium shows. Now let's see about the chemical properties of gallium. It is non-reactive in dry air, but in moist air, it forms a protective oxide layer on the surface, just like aluminium does. The gallium burns in air to form a white oxide, which is gallium oxide Ga2O3. This oxide can be reduced to metal when it is heated at high temperature in the presence of hydrogen. Now, gallium reacts with water only after 100 degrees Celsius. That is, below 100 degrees Celsius, gallium is unreactive in water. The most common oxidation state of gallium is +3. Gallium dissolves in both strong acids and in alkalis, except cold nitric acid. Why? Because of the protective oxide layer on its surface. Gallium reacts with acids to form salts. That is gallium salts. Gallium react with alkalis to form galates. And in galates, gallium is present as anion. Okay. There is also evolution of hydrogen gas when gallium reacts with alkalis. Since we have seen that gallium reacts with both acid and bases, so it is amphoteric in nature. Now, gallium is attacked by halogens vigorously. Now let's see some of the interesting behavior of gallium. There is large difference in melting point and boiling point, due to which gallium shows some of the interesting properties. Solid gallium melts in hand. It expands on solidification. It makes aluminium and steel brittle. We're going to discuss all of this one by one. Let's see, due to large difference in melting point and boiling point of gallium, what are the different properties it shows. So we have already seen that melting point of gallium is 29.7 degrees Celsius and room temperature is around 25 to 27 degrees Celsius. But due to global warming affecting our planet Earth, most of the time in a year, room temperature is little greater than 29 degrees Celsius. As a result, gallium becomes liquid at room temperature. So technically, gallium should be solid at room temperature, but practically is found in liquid state. Now let's see another interesting behavior of gallium. When you keep solid gallium in your hand, it becomes liquid. That is, it melts right in your hand. Why does this happen? Now we know that our normal body temperature is 37 degrees Celsius and melting point of gallium is 29. So gallium gains heat from our hand and melts right in our hand. Also, when you pour gallium back on any surface, it re-solidifies. The gallium has high boiling point of 2204 degrees Celsius. Such a large difference. In fact, gallium is one of the metal with such large difference in melting point and boiling point, and this unique property of gallium is used in its application. But why so much large difference is there? Answer is based on a very simple concept of bonding force. And this is an assignment for you all. Please write its answer in the comment box. Let's see another unique property of gallium, that is it expands on solidification. Gallium is among few metals which expands on solidification, that too approximately by 3%. That is that is solid gallium is less dense than liquid gallium, which means solid gallium will float on liquid gallium. Generally, any substance contracts during solidification, but there are some exceptions like germanium, bismuth, antimony, mercury, water, and gallium. Now, we all have seen water, that is ice, floats on liquid water, right? That is because ice expands on solidification and it is less dense than water, so it floats. Now, we are going to see another interesting properties of gallium, that is, it makes aluminum and steel brittle. Now, let's watch this video. In the video, first good amount of liquid gallium was poured on aluminum can. After some time, it solidified without affecting the can. In second case, the can was first rubbed with emery paper and then a drop of liquid gallium was kept on the can. After some time, gallium got diffused into the can and the can was easily broken with bare hand without applying any pressure. How this happened? In first case, there was a protective layer of aluminum oxide on the can due to which gallium could not diffuse inside aluminum. So nothing happened to the can and gallium just solidified. But in second case, this layer was removed when the can was rubbed with emery paper. Now liquid gallium was in direct contact with pure aluminum, and so gallium diffuses rapidly into the crystal of aluminum and forms aluminum gallium alloys at grain boundary. Now, this alloy is brittle in nature and it weakens the bond of aluminum atoms and makes aluminum also brittle. Brittle. Due to this, you can break aluminum can into pieces with hand. That is, aluminum, which was malleable and ductile, becomes brittle with only one drop of gallium. Now, gallium affects steel in the same way. Now, let's see about occurrence of gallium in nature. In nature, gallium does not occur in pure form. It is found in trace amount with minerals such as diaspore, sphalerite, bauxite, and coal. Now, gallium is more abundant than lead, but less accessible as it is not concentrated into one mineral. Gallite, which is CuGas2. Now, this is the only mineral of gallium, but is rare and economically insignificant. Gallium is not particularly extracted, but it is obtained as byproduct of zinc refining and during processing of alumina from bauxite. It is also recycled from scrap generated from the manufacture of gallium arsenide and gallium nitride. In India, gallium is recovered as byproduct while processing alumina from bauxite at Hindalco, which is in Uttar Pradesh, and Nalco, which is in Odisha. Now we are going to see uses of gallium, which is very important. Okay. Gallium is known as a strategic metal. So what do we mean by strategic metal? Strategic metal are those whose raw materials are critical to modern technology and industry, but whose supply is limited and or disrupted. Iron, copper, and zinc. These are base metals as availability of these metals are abundant around the world. If we talk about gold and silver, these are precious metal but not strategic as they are not vital to technology and industry. Gallium, along with antimony, indium, beryllium, and rare earth metals, are strategic metals. Now, gallium is extensively used in semiconductor industries. Semiconductor industries depend on silicon for production of wafer, which finds use in everything from refrigerator to cars to microwave ovens and to smartphones. But there is global shortage of this wafer due to long time taken for its production. As it is said, necessity is the mother of invention. Gallium nitride was invented, which is all set to replace silicon from wafer used in making semiconductors. As gallium nitride is easier and faster to produce than silicon, as well as environment friendly, more efficient, and smaller. The two alloys of gallium, that is gallium arsenide and gallium nitride, which we just discussed. These are boon to today's world and are used increasingly in the production of LEDs, solar cells, solar panels, smartphones, and Blu-ray technology. So you can see that the area of application of gallium are all related to modern technologies. There are some other use of gallium also, like it is used as a coolant in nuclear power plant, is used in medical imaging. Liquid gallium is used in high temperature thermometer due to very large difference in melting point and boiling point. The eutectic alloy of gallium, indium, and tin is replacing mercury in fever thermometer also, as mercury is poisonous. So these were all about the uses of gallium. In this video, today we have discussed about gallium, its physical and chemical properties, interesting behavior shown by gallium, that is, it melts in our hand, it expands on solidification, it makes metal, especially aluminium and steel, brittle. We have also seen about occurrence of gallium in nature and how it is extracted. We have seen about uses of this metal. Right? So from our discussion, we can say that the demand for gallium is going to inflate with growth of electronics and communication industries. Gallium. Also, world is shifting to solar energy, and gallium has its application in production of solar cells and solar panels. Also, gallium is used in nuclear reactors. So these are the areas which are on the increasing trajectory path of future, and this makes gallium metal a smart future metal. With this, I came to the end of our video. If you like the content of my video, then please like, share, and subscribe. Thank you.